Okay, this tutorial deals with section 1.3, and that's a radian measure. And if you remember, the unit circle is important, and that's what I have here, because it's a circle with a radius of 1 that starts at the origin. And when you're drawing a unit circle, you have some angle given with some radius r and some arc length. The radian measure of that angle is the relationship between this radius and arc length, and it's given in radian measurements, which is different than degrees. And the thing that we need to know in this section specifically is that one revolution around a circle is 360 degrees, or 2 pi radians. Those are equivalent units. Therefore, pi radians is the same thing as saying 180 degrees. Okay, so we're going to start by converting 261 degrees into radians to 4 decimal places. So what you do is you use a ratio setup. So we know that 180 degrees equals pi radians. So that's our given. So we can do a similar type of ratio for finding the degrees, the radians given degrees. So if we have it here where we have that, so we put our 261 up here. And we put X number down there for so many radians. Okay, so what we'll do is we can cross multiply here. So 261 pi is equal to 180x, where x is the measure in radians. So divide by 180. And you can get a value for x. So now, if you were going to leave it in pi radians, you would just reduce this fraction here. But since we're asking for 4 decimal places, what we can do is we can go take our calculator here and go 261 times pi, which if you want to use your pi button on your calculator, you can. It would give you more decimal places. Let me see if I have one on this calculator here. Doesn't look like it has a pi button. So if you don't have a pi button, you can just use 3.14. And then we can also divide by 180 to get 4.553. Obviously, I probably should use a more accurate value of pi if I want to go to more decimal places. That's radians. But since I don't have it on my calculator, we'll just go there. Okay, a similar thing, if you had sometimes you can get perfect reducings here. So if I had 300 degrees, so I got 180 over pi, that's the ratio, is equal to 300 over x. So 180x equals 300 pi. Divide by 180, x is equal to 300 pi over 180. Now we can reduce it, take a 10 out. 30 over 80, well, 3 can come out of both, or even 6 can come out of both. 6 out of 30 is 5. 6 out of 18 is 3, so it's 5/3 pi. Okay, so sometimes if you can get a nice reducing in the fraction area, you keep the value of your radians with the pi measurement there. Okay, if you wanted to convert it to decimals, then you would just multiply this value by 3.14. So we'll flip over here, and we'll do the next question. Asks us to convert 2/3 pi radians into a decimal degrees to 4 places. So it's similar to what we were doing, except we changed places here. Still use the 180 over pi, except the x is on top, because now the 2/3 pi goes here. Okay, so that's the radian measure on the bottom. That's the radian measure on the bottom. The degrees, the degrees. So then we have 180 times 2/3 pi is equal to pi x. So if we divide by pi on both sides, they cancel out there. So x is equal to 2/3 times 180. So we'll just take 180 times 2 divided by 3. So that's 120 degrees. Okay, so it works out to a nice even number. Find the value of sine 3.85 if the angle is in radians. Okay, so there's a couple of ways you can do this, and this will be our last question in this section. And if you're going to do your calculator method, you have to just simply be careful on how you set your calculator. So if you look at my calculator here, it's in degrees, but I can shift it into radian measure by going shift, or not shift, clear, mode actually, put it in the radian mode, which is for me mode 5. Then you'd see a little rad on top of your calculator. Then all I have to put in is 3.85, and then I can take the sine. And that would be, and this is in radians, would be equal to negative 0.6506. Okay, alternatively, if you don't have radians, you could convert it into a decimal number, decimal degree number, and then take the sine value of it. But just be careful with your calculator that you always have it in the right mode. Okay, in the next section, we'll be looking at 1.4, which is dealing with angular and linear velocities.